So first you're supposed to write the equilibrium constant expression, and you start with products of reactants. So you're going to have KEQ equals the concentration of H plus times the concentration of C3H5O2 minus over the concentration of HC3H5O2. So that's part A. And then for part B, you're supposed to calculate the pH of a 0.265 molar solution of propanoic acid. So to do this, you're going to use ice. So you have the equation, and you start with 0.265 molar of propanoic acid. So to do ice, and then you have 0 of and 0 of both of these. So you add x and subtract x. So you have 0.265 minus x, and you have x and x. So then you plug this into your equilibrium expression, and you're given the Ka. So you have 1.34 times 10 to the negative fifth equals x squared over 0.265 minus x. But you ignore the x on the bottom because of the 5% rule. So when you solve and plug that into your calculator, you have x equals 1.88 times 10 to the negative third molar, and this equals your H plus. And then because of the molar ratios, your H plus also equals your C3H5O2 minus. So that, and then what you're trying to find is the pH. So you're going to do the negative log of 1.88 times 10 to the negative 7, because that is your H plus concentration, and that equals 2.7. So 2.7 is your pH.
Okay, so for part C, you're trying to find the concentration of the propanoate ion in the new solution that you're given. So what you do is you know the grams of sodium propanoate that you're given. You're given 0.496 grams, and you use stoichiometry to find the moles of that. So you know the molar mass is 96 grams. So you divide 0.496 by 96, and you get 5.17 times 10 to the negative third moles of sodium propanoate. And then you know by the equation that you're given that the moles of sodium propanoate equal the moles of C3H5O2. So you do 5.17 times 10 to the negative third moles C3H5O2. And then to find the molarity of that, you divide it by the volume you're given, which is 50 milliliters, so 0.05 liters, and that becomes 0.103 molar. And then for part 2 of C, you use ice to find the concentration of H+. So you have HC3H5O2 giving C3H5O2 minus plus H+, and then you use ice, and the concentration that you're given in the beginning is 0.265, and the concentration you just found is 0.103. Then you do plus x minus x, 0.265 minus x. And then you are given the Ka, which is 1.34 times 10 to the negative fifth, and that will equal x times 0.103 over 0.265, and you can ignore the x's because of the 5% rule. And so you come out with x equals 3.45 times 10 to the negative fifth, which equals your concentration of H+.
Okay, so for the first part of D, you are trying to find the value of Kb. So first you want to write out the equilibrium constant expression. So Kb equals the concentration of OH minus times HCO2H over HCO2 minus. So you're given that the OH minus concentration equals 4.18 times 10 to the negative 6 molarity. And because of the molar ratios, you know that this also equals the concentration of HCO2H. So and then you are also given that this is a 0.309 molar solution of sodium methanoate. So you're going to plug this in, so you have Kb equals 4.18 times 10 to the negative 6, and you can just automatically square this because this is the value for the OH minus and the HCO2H. And this is going to all be over 0.309. So when you put this into the calculator, you get your Kb as 5.65 times 10 to the negative 11. Okay, for part 2, all that you're doing is finding the value of the Ka. So you know Kw equals 1.0 times 10 to the negative 14th, and Kw equals Ka times Kb. So you do 1.00 times 10 to the negative 14th divided by the Kb that you found, which is 5.65 times 10 to the negative 11th, which gives you 1.77 times 10 to the negative 4, and this is your value for the Ka.
Okay, so for part E, they're asking which acid is stronger, propanoic acid or methanoic acid, and we know that methanoic acid is stronger because it has a larger Ka value.